Hello, and thank you for watching this video about tides. So what exactly are tides? Tides are the rise and fall of water in the ocean. So here in Michigan, on any of our lakes, we don't have tides. To see and experience tides, we have to be at an ocean. The water rises and falls very slowly over the course of about 12 and a half hours and repeats over and over. Over the course of about 6 hours, the ocean water slowly rises. Then over the course of the next 6 hours, the water slowly falls. When the water is highest, that is called high tide, and when the water is lowest, that is called low tide. Something I want to make abundantly clear is that tides are not the same thing as the waves that come in and crash on the beach every few seconds. Tides are a very slow change that takes place over the course of hours. See for yourself. This short clip will show you a time-lapse video of the Bay of Fundy in Canada, which has the biggest tide change in the world. The video was filmed over many hours, but sped up very quickly so that you can see the tides change. So what exactly causes the tides? In order to understand tides, we need to understand gravity. Remember that gravity is the force that attracts everything in the universe toward each other. You and I are very small, so our gravitational pull on objects around us is super tiny. However, things like Earth, the moon, and the sun are very massive, so they have strong gravitational pulls on us and on each other. Tides are caused by the gravitational pull from the moon and the sun. So how does that work? First, think of the Earth as a ball surrounded by a layer of water, as shown in this image. The layer is really much thinner than this, but is drawn thicker, so it is easier to see. But the water is not evenly spread around the entire Earth. Instead, the moon is nearby and has a gravitational pull on both Earth itself and the water on Earth. The moon's gravity pulls quite strongly on Earth's water that is facing the moon, as that water is close to the moon and is loose and can move around. This creates what we could call a bulge of water on the side of the Earth that is closest to the moon. With all that extra water, that creates a high tide. The moon is also pulling on Earth as a whole, which is why there's an arrow at the center of Earth, but it's not as long or as big because the moon isn't pulling on the entire planet quite as strongly as the water that's closer to it. But this pull of the moon actually causes the Earth to be pulled toward the moon a bit. When it comes to the water on the far side of the Earth that is far away from the moon's gravitational pull isn't as strong because that water is further away. Since that water isn't being pulled as much as the whole planet Earth, that water is kind of left behind, and that creates another bulge and another high tide on the other side. Halfway between the high tides, the water is being pulled to either side, which results in less water, meaning a low tide is there. So on this diagram, The high tides would be here and here, and then low tides would be here and here. So at any given time, there are two areas on Earth where there's a high tide and two areas on Earth where there are low tides. As Earth rotates or spins, the water rises and falls throughout the day as different areas of Earth spin into and out of high and low tides. Remember how I said that it's both gravity from the moon and the sun that causes the tides? It's true. Even though the sun is about 150 million kilometers from Earth, it is so massive that its gravity affects the tides too. Since the moon is so much closer, though, the moon's gravity affects the tides more than the sun does. With both the sun and the moon pulling on Earth and its water, where all of them are located determines how high and how low the tides are. First, we will examine what we call a spring tide. A spring tide is a tide with the greatest difference between the high and low tides. This means that the high tide's water is really, really high, and the low tide's water is really, really low. This occurs when the sun, moon, and Earth are in a straight line with each other. The sun's gravity and the moon's gravity are pulling on Earth and its water together in the same direction. Their forces combine to pull a ton of water, creating high tides that are extra high, and the low tides are extra low. The moon could be in its new moon phase in between the sun and Earth, or on the other side, where the moon would be in its full moon phase. It doesn't matter in which order the sun, moon, and Earth line up, because high tides are created on both sides either way. A different type of tide, called a neap tide, occurs when the moon is in its first quarter phase and in its third quarter phase. In each of these phases, the line between Earth and the sun is at right angles to the line between Earth and the moon. The sun is pulling in one direction, and the moon is pulling at a right angle to the sun's pull. This arrangement produces a neap tide, which is a tide with the smallest difference between high and low tide. This means that the high tide isn't really that high, and the low tide isn't really that low. So there isn't a huge difference between the two. We can see that the high tides are in line with the moon's location, and the low tide is in line with the sun's location. The moon creates a bigger bulge of water because the moon is so much closer to Earth than the sun is. The sun is too far away, so its pull is smaller, and the bulges that it creates on each side of Earth are smaller. Since both the sun and the moon are pulling, but in different directions, it's like the water on Earth is shared, and the high tides aren't quite as high, and the low tides aren't quite as low. So why should we even care anyway? Well, you and I might not care so much because we live in Michigan and not near an ocean. However, there are many people who should make it a habit to monitor or watch and pay attention to the tides. Anyone who is driving a boat or a ship on the ocean should pay attention to the rise and fall of tides. Some areas that a boat might need to travel through might have shallow water that is not very deep, especially through a port or a channel. At a low tide, an area where they dock their boat or an area where they want to travel through may have water like this that is too low to go through. If they are aware of the tides, they can be aware of this and plan accordingly so they don't get stuck somewhere. Fishermen should also pay attention to the tides. They drive boats, so they should pay attention for the same reasons I just mentioned, but also because knowledge of tides can be helpful when fishing. Depending on the depth of the water, fish may be found in different places. So, if a fisherman goes to the right spot, they will be more likely to catch fish. They should be aware of what the tides are doing so they can best decide where to go to catch the most fish. Construction workers who are building bridges or docks near or on the ocean should also pay very close attention to the tides when they work and when they're planning their work. First, they need to make sure that they know how high can get in an area so they build high enough so what they're building won't get covered in water. But they also need to make sure that they have space to work and not get covered with water while doing so. They may need to plan construction far in advance to make sure they're building at the right time and know exactly what the tides will be like. It might also be a good idea for swimmers and surfers to be aware of the tides. If you go to the beach at an ocean and lay down all of your belongings and then go into the ocean for a while, you may be surprised to find when you get back that your stuff has gotten all wet. This might be because the tide was rising as you were swimming, and the water was coming up closer and closer to where you put your things down. Eventually, the water might get your stuff wet, or even worse, carry it out to sea. Surfers should also be aware of the tides, especially if they are in an area that is rocky. At low tide, there might be a bunch of rocks that are exposed and not covered in water, so they could get in the way and cause injury. Depending on the tide, the waves may break in different locations that might be too close to rocks or too close to a beach, or the waves may break all at once instead of spaced out. Surfers should be aware of the tides and how they impact waves so that they can choose the best locations and the best times to go surfing.